Alright, in this lesson we are going to identify vertical transformations, also known as changes, given in function notation. So basically we're going to take some functions and we're going to change them. Now, if we look at this first one, we have f of x equals x. Remember, this is the apparent linear function, so this is the most basic line, so to speak. So if x is 0, y is 0, x is 2, y is 2, x is 5, y is 5. Now if we take that function and we subtract 4, we end up with this red one right here. If we take that same function, or you take the y's of that function, and you add 4, you end up moving to this line. Now it's not really that difficult to see how you would get from this line to this one, or from f of x to f of x plus 4. All you're doing is taking this original function, taking all the y's, and we're subtracting 4 from them. So we end up translating this function down 4 spaces. It works anywhere. 1, 2, 3, 4. Remember, because you took this y value here and you took 4 away from it. Should work the opposite way in this one. If we took all the y's in this function, like this as part of the solution, then we added 4. 1, 2, 3, up 4. 1, 2, 3. We are increasing them by 4. Should work for, well, it does work for any function. So this is our original blue. Our original's blue. So this is our parent quadratic function. So we took our parent quadratic, which is x squared, so 0 times 0, or 0 squared is 0. 1 times 1 is 1. 2 to the second power is 2. 3 to the second power is 9. Negative 2 to the second power is also 4. Negative 3 to the second power is also 9. Just as a quick reminder. Now, it should work the same. You took all the y's and you subtracted 4. You took all the y's, subtracted 4, so you move down 1, 2, you translate down 4. Let's take this one. 1, 2, 3, 4. Remember that these are also all points. I'm just choosing the nice integer value ones. And if we took all the y's, or we took the function and we added 4, then 1, 2, 3, 4 up. 1, 2, 3, 4 up. So on and so forth. Also works for cubic functions. You could see 1, 2, oh, this is our original, so down 1, 2, 3, 4. This is our original here again. Let's choose this one. 1, 2, 3, 4. So it works the same for all functions, no matter what function you start with. So if we subtract from f of x, then the function will translate down. If we subtract, it translates down. If we add, we translate up. That's when we add and subtract from f of x in function notation. Let's see what happens when we multiply. Now, if we look at this, we have our original linear, parent linear function. So, and we multiply f of x by 5/10. We start off with this blue, and then somehow we end up with this red line. When we multiply by 2, we start with this blue, but we end up with this red line. It's kind of hard to see in that way. So let's try quadratics. Quadratics are sometimes nice to see transformations on. So we have 5/10. So our blue one was here. When we multiply by 5/10, it looks like we get wider. It looks like we get wider like this. And when we multiply by 2, it looks like, remember that blue is the original, it looks like we get skinnier or narrower. But remember, we're dealing with vertical changes, up and down changes. We're not dealing with left and right changes. So this won't work, this won't work. This won't work, this won't work. So how do we get there using up and down? Well, instead of stretching it side to side, you're actually pushing, you're compressing the function towards 0, 0, or towards 0, I mean. So basically, you're squishing it. You can see it, you're squishing it. So when you squish the blue, you get the red. And this one, instead of squishing, you're kind of like pulling in opposite, like vertically in opposite directions. So you end up making it skinnier. Like think about Play-Doh. Like you're pulling it vertically, ends up skinnier. And the same with this cubic. It's just harder to see. So I'm going to focus on this A, the number we're multiplying by. I want you to ignore whether it's positive or negative. I don't want you paying attention to that right now. If this is a number that's less than 1, like this one, like when it was less than 1, we compressed it. When it was larger than 1, this digit, the absolute value of A, then you're stretching it. So digit between 0 and 1, so absolute value between 0 and 1, then you will compress. When it's a digit larger than 1, then you will stretch. Alright, we got one more. Let's see what happens when you have this like negative sign in front. So our original, and then like it like crosses like in the opposite way. But what does that even mean? Let's see. Okay, this is easier to see. It went from opening upwards to opening downwards. Oops. And this one is kind, I don't know. I mean, this part opened up or went up and now it's going down. This part was going down, now it's going up. Okay, so let's go back to quadratic. It's probably the easiest. So when you multiply your y's by -1, or you change them to the opposite sign, which is what this does, then it flips, so to speak. In other words, it's a vertical reflection. So it's reflecting. And let's try this one. Sorry, it's a little weird. This one was our original. So it's reflecting. That part's coming down here. This part's coming up here. It's reflecting vertically, so to speak. It's flipping. This part was like, now it's flipped over here. This one's flipped over here. Now remember, when you reflect vertically, in this case, you are not going over the y-axis, which would be like this. You're going over the x-axis. So if you multiply f of x by a negative number, or just, like this is -1. -1. I tried to make that neater. Then the function will reflect vertically over the x-axis. Alright, we got one more page and then we'll be done. Alright, so I summarized all that. Well, I restated that. They're all right here. You can see. Now, I'm going to show you how to do the practice. If we took f of x and we took away 5, remember, we took away 5. So minus a number translates the function down. So it translates down 5 units. That was easy. This is the one we just did. When you have this, it's going to be a reflection. And it's going to be a vertical reflection, so it's going to be like that. So that's over the x-axis, not the y-axis. Now remember, the 5/10, this will be like wider. Like it says, between 0 and 1 digit. It's going to be wider. If it's wider, then we're going to be pushing, we're going to be compressing. So vertical compression by a factor of 5/10. Well, there's more than one here. I like doing translations first. They're the easiest. So we add 4. So that means we're going to move up 4. We're going to translate up 4 units. But then once again, we have this reflection over here. Vertical reflection. Remember, vertical one more time. You'd be flipping over the x-axis. Alright, this is easy to see again. The reflection over the x-axis. Easy. So that part's done. Now this. Just because it's a fraction, like, don't forget about it. This is 4/3. It's larger than 1. It's more than 1 whole. If you want to convert it into decimal form, it's 1 3/10 repeat. 1.33 repeating, we'll say. So that's larger than 1. So if it's larger than 1, that means, let's see, larger than, greater than 1, without the sign. Vertically stretch. Remember that instead of looking like this, it ends up looking like this. So vertically stretch by a factor of 4/3. We're going to leave the negative out because we took care of the negative with the reflection. Okay? So thank you very much.